Blood circulation notes. Average adults have 5 liters of blood circulating through them. So try to visualize what 5 liters really looks like. You've probably heard of a 2-liter bottle of soda. So you got 2 2-liter bottles, and you got another liter somewhere. I tried to go through the kitchen. I don't know why we have 2 half-used soy sauces, but we do. And that's about 5 liters. So visualize anytime you see numbers what that looks like, and that's about how much blood you have going through you at any given time. When the body needs to circulate more blood, the heart can beat faster or harder. So we're going to talk about each one of those in turn. I've color-coded them. Because you only have 5 liters, you have to make it go around a lot faster. Or you can pump more at a time. Heart rate is the number of times the heart beats each minute. So if you feel your pulse, we've done that in class. You can feel it either on your wrist or on your neck. You count the number of times you feel the heartbeat each minute, and that's your heart rate. An average heart rate is 70 beats per minute, and we measure that in BPM. Believe it or not, the heart rate is controlled by the heart itself. So if you think about when someone has a heart attack and they do those electric paddles, they don't paddle the brain, they paddle the chest. And that's because the chest, the heart, is what is controlling its own self. We're going to talk more about that next week. But if you never thought about that, it's kind of a cool idea. It's the only organ that really isn't controlled by the brain most of the time. It is, however, affected by age, hormones, and fitness level. Now, when we say affected by, it means it could either be increased or decreased. So, for example, heart rate decreases with age. Little babies have really fast heart rates, and then as you age, it gets slower until old age, and then it actually starts to rise again. Hormones, we're talking about adrenaline. So when you have adrenaline, as you have felt, your heart rate increases. And then fitness level, we'll talk about that in a minute, but the more fit you are, usually the lower the resting heart rate. Now, stroke volume. This is the idea that if you need to beat harder, if you have a water bottle, let's say, and you squeeze it hard, you're going to get more water to come out. So the stroke volume, or SV, is the amount of blood the heart pumps each beat. And if the heart pumps harder, then you get more blood each beat. An average stroke volume is 70 milliliters, more or less. It's affected by your body size and fitness level. And again, affected by could either be increase or decrease. Your body size, as you get taller or larger, like fatter, your stroke volume increases because you have a bigger heart. And then as your fitness level gets higher, your stroke volume also gets higher. Now, when you put the two together, you have your heart rate and your stroke volume, you get the cardiac output. The cardiac output, which we abbreviate Q for some reason, is the amount of blood the heart pumps each minute. So if you are understanding how we put these together, you have the amount of blood each beat, and you have the number of beats. When you multiply them, you get the amount of blood each minute. So, an average cardiac output is about 5 liters per minute. And our equation there is Q, cardiac output, equals HR times SV. Now we have some circulation adaptations to exercise. So as you exercise, you change your cardiac output, your stroke volume, and your heart rate. So trained athletes are special in 3 to 4 ways. Trained athletes have larger stroke volumes at all times. And so if you think about why, well, the stroke volume is essentially how much blood your heart can squeeze out. And so if the heart is stronger, it can squeeze out more. So they have larger stroke volumes at all times because their heart muscle is stronger. They have a lower resting heart rate because of that larger stroke volume. So the idea is if they can pump more blood each beat, they don't need to beat quite as fast. And so when they're at rest, their heart rate is really low. They have a higher max heart rate. So if we were to get on a treadmill, a trained athlete could get their heart rate a lot higher than I could. Well, why is this? You might think, oh, it's because, I could still get tired. Well, why? Because my cells will run out of oxygen, whereas they have blood that can carry more oxygen in their hemoglobin. And so when you think about endurance, trained athletes can endure a lot longer because they can deliver more oxygen with each heartbeat. The next idea is about cardiovascular drift. Any person doing the same intensity exercise for a long time will experience cardiovascular drift. So visualize you're on a treadmill, you're not changing the speed or the incline, and you're just doing the same pace for like an hour. What's going to happen? Well, you might think, oh, I'm going to become tired, sure, but what's going to happen to your heart rate? If you're not changing your intensity, you might think your heart rate wouldn't change. But in fact, cardiovascular drift is a gradual increase in heart rate. Now we know that heart rate is related to stroke volume. So why does the heart rate go up? It must be because the stroke volume went down. So it happens because of a decrease in blood volume from sweating. Now, you're like, I've never sweat blood. I think if you sweat blood, you have a problem. I shouldn't be oozing red liquid, right? But remember that blood is made of the liquid plasma. That's what carries everything around in the blood. And plasma is 90% water. So when you sweat out water with some salt, where does that come from? Well, it comes from your blood. And so there's less blood, like liquid, in your blood when you've sweat a long time. And your blood actually gets a little bit thicker. And because there's less volume, in order to keep the same cardiac output with a lower stroke volume, the heart rate rises. And our equation here is that Q equals stroke volume times heart rate. And so if stroke volume goes down, heart rate has to go up in order to keep the same cardiac output. Now, obviously, this isn't good. You don't want to increase your heart rate. So what do? Easy. You drink liquid. And that's why people, if they are running for a long period of time, just drink liquids, or whether water or Gatorade or Powerade. Just get that fluid back and you will not experience cardiovascular drift. Thanks for watching.